This is the video solution to an example problem with rotational kinematics. A potter sits at the potter's wheel shown below. When she kicks the wheel in the bottom, she changes its angular velocity from pi over 2 radians per second to 3/2 pi radians per second in 0.1 seconds. What angular acceleration did she give the wheel? The disc on the bottom has a mass of 51.5 kilograms. To begin with, I'm going to start by looking at my givens, looking at unit clues and any other clues I have in the problem. So in terms of unit clues, I know I have radians per second. That's going to be my velocities, and the pi over 2 is the beginning of the story. The 3/2 pi, that's at the end of the story. So those are my angular velocities. The time is 0.1 seconds, and the mass gives me to be 51.5 kilograms for that big disc at the bottom of the wheel. The strategy I'm going to use in this case is I'm just going to go with the definition of angular acceleration. So the angular acceleration is the final angular velocity minus the initial angular velocity divided by time, and I'll use that to determine the acceleration. And as it turns out, the mass is just extra information I didn't need. So I'm going to solve with the angular velocity. There's my equation, alpha being my angular acceleration and omega being my angular velocities. Now I'll put in my numbers with the units and then do a little bit of math, and I get pi radians over 0.1 seconds. So that ends up being 31.4 radians per second squared as the angular velocity.